Welcome to Easy Method Circuit. In this video, we'll be looking at Ohm's law and how to apply it into circuit analysis. Ohm's law is named after a German physicist named Georg Simon Ohm. In one of the experiments he carried out, he completed a live circuit with his hands and he observed the amount of electric shock he received. He observed that with a higher voltage in the circuit, he received a higher shock, and with a lower voltage in the circuit, he received a lower shock. And he therefore concluded that the amount of current flowing in a circuit, which is responsible for the electric shock he received, is dependent on the magnitude of voltage that is supplied to the circuit. Given that all other external parameters are constant, Ohm's law states that the amount of current flowing in a circuit is directly proportional to the voltage supplied to the circuit. And you can easily say the voltage is directly proportional to the current. The voltage is measured in volts, symbolized with V, and the current is measured in ampere, represented with I. So from here, we can easily say our voltage is directly proportional to the current. To introduce the constant of proportionality, we can say V is equal to the constant and the current. This K, which is the constant, is what we know as the resistance. For a circuit to perfectly obey Ohm's law, the resistance must be constant. This resistance is measured in ohm, represented with the symbol ohm. So from here we can easily say that our V is equal to Ri, the resistance be the constant. And by rearrangement, we can have V to be equal to IR. We have V to be equal to IR. From here, if we have a constant value of resistance to be 2 ohms, we can see that our V will now be 2I, the resistance being 2 ohms. With a constant value of resistance, if the voltage is 2 volts, that means we have a current of 1 ampere. If the voltage is 4 volts, that means we have a current of 2 ampere. If the voltage is 8 volts, that means we have a current of 4 ampere. If the voltage is 10 volts, that means we have a current of 5 ampere. Now, if you plot the value of your voltage against your current, we have the voltage in this axis, we have the current in this axis. We can see that the higher the voltage goes, the higher the current also goes with a constant resistance. So if we plot the value of the voltage against the current, we have a linear graph like this. And if you find the slope of the graph at any point, we obtain a constant value, and that constant value is going to be the same value of the resistance. We have V to be equal to IR. If we divide both sides by resistance, this will go with this. Then we have the current to be equal to the voltage over the resistance. If we divide both sides by the current, this will go with this. Then we'll be left with the resistance to be equal to the voltage over the current. From these three mathematical expressions, we have the voltage to be equal to the current and the resistance. We have the current to be equal to the voltage over the resistance. We have the resistance to be equal to the voltage over the current. To easily remember these mathematical expressions, that leads us to what we know as the ohmic triangle. The ohmic triangle looks like this. This place is occupied by the voltage, this place is occupied by the current, and this place is occupied by the resistance. To easily use the ohmic triangle, if you want to get the mathematical expression of the voltage, if you take away the voltage from the triangle, you observe that you are left with the current and the resistance. So that means the voltage is equal to the current multiplied by the resistance. If you take away the current from the triangle, you observe that you are left with voltage over the resistance, which is the same as the current. Now let's replace, and if you take away the resistance from the triangle, you are left with the voltage over the current, and that gives us the resistance. So the ohmic triangle is a great tool that helps us to easily remember the mathematical expressions of Ohm's law. Ohm's law can both be applied to an AC circuit or to a DC circuit. But for Ohm's law to be applied to an AC circuit, the circuit should not consist of reactive elements. The active elements are your inductor or your capacitor. An AC circuit that is consisting of reactive elements, for it to obey Ohm's law, the frequency of the circuit should be constant. Being that for DC circuit, we have the voltage to be equal to the current and the resistance. But for an AC circuit, we have the voltage to be equal to the current and the impedance. So for an AC circuit to obey Ohm's law, the frequency of the circuit must be constant, because the impedance, which is representing the resistance here, the impedance which is standing in for the resistance, is also dependent on the frequency. Therefore, for an AC circuit to obey Ohm's law, the frequency must be constant. But in this video, we'll be applying Ohm's law to DC circuits. We will talk about impedance in one of our videos to come. We have V to be equal to IR, we have I to be equal to V over R, we have R to be equal to voltage over current, given a DC circuit in this form. Some of us, we may know our resistance to be represented by this symbol, but for the purpose of this video, we'll be representing our resistance with this symbol for easy drawing and to save our time. If we have a voltage source of 6 volts and we have a load of 4 ohms, and we are to find the current that is flowing in the circuit, from our formula here, we see that current is equal to the voltage over the resistance. So our current will be what? The voltage over the resistance, and that is going to give us 6 over 4. And that will give us 1.5. The amount of current that is flowing in this circuit is 1.5 amps. If we have a DC circuit to be in this form, we have a voltage source of 6 volts and the current of 2 amps is flowing in the circuit, and we have to find the resistance. Given that the resistance is voltage over current, that means we are going to have the resistance to be equal to 6 volts over 2 amps, and that is going to give us 3 ohms. If we have another simple circuit to bring in this form, the resistance to be 4 ohms and the current of 2.5 amps is flowing in the circuit, and we have to find the voltage. The voltage being the product of the current and the resistance. That means we have 2.5 multiplied by 4, and that is going to give us 10 volts. So the voltage that is energizing this circuit is 10 volts. The resistance of this circuit is 3 ohms, and the current that is flowing in this circuit is 1.5 amps. Now let us apply Ohm's law to a series circuit, a circuit that is consisting of 2 resistors. We have a voltage source here. We have 2 resistors in series. A 24 volt is powering the circuit. We have 9 ohms resistor here, and we have a 6 ohms resistor here. To find the current that is flowing in this circuit, the formula for the current is equal to the voltage over resistance. But in a series circuit, to find the equivalent resistance of a series circuit, you find the sum of the resistances. That means in this circuit we have our current to be voltage over the first resistance plus the second resistance. That means we'll be having 24 volts over 9 plus 6, and that is going to give us 24 over 15. So that will give us 1.6 amps. That means a current of 1.6 amps is flowing in this circuit. To find the amount of voltage that is dropped across each resistors, the amount of voltage that is dropped across each resistors, what you do is you just multiply the current, since the same current is flowing in the circuit, because in a series circuit there is only one path for current flow. So what you do is you just multiply the current that is flowing in the circuit by the resistance. To get the voltage that is dropped across this 9 ohms resistor, we have V to be equal to IR. That gives us 1.6 multiplied by 9. 1.6 multiplied by 9. 1.6 multiplied by 9 is going to give us 14.4 volts. That means a voltage of 40.4 is dropped across this 9 ohms resistor. To get the voltage that is dropped across this 6 ohms resistor, we have V to be equal to IR. Since we have a current of 1.6 amps flowing through the resistors, then multiplied by the resistance, and 1.6 multiplied by 6, that is going to give us a voltage of 9.6 volts. Now if you find the sum of these two voltages, the voltages that are dropped across the resistors, if you find the sum, if you find 14.4 plus 9.6 volts, that is going to give us 24 volts, and that is equivalent to the sum of the, that is equal to the voltage that is energizing the circuit, which is a correlation of Kirchhoff's voltage law, which states that the algebraic sum of the voltage in a loop is equal to 0, or the voltage that is dropped across the circuit is equal to the voltage that is supplying the circuit. Don't forget to click the subscribe button below. Now let's apply Ohm's law to a parallel circuit. If we have a voltage source at this side, we have a resistance here, we have another load here, and we have another load here. All of them are connected in parallel to the voltage source. If we have a 12 voltage source here, we have a load of 3 ohms here, we have a load of 4 ohms here, and we have a load of 6 ohms here. To get the current that is flowing in each of the loads, let's denote the current that is flowing in the first branch to be I1. Let's denote this one to be I2, and this one to be I3. In a parallel circuit, the loads have the same voltage across them. Since all of these loads, all of the resistors are connected in parallel to the voltage source, they have the same voltage across each of them. The 3 ohms have a voltage of 12 volt across it. The 4 ohms resistor have a voltage of 12 volt, and the 6 ohms also have a voltage of 12 volt across it. So to get our I1 in this circuit will be the voltage over R1, and that is going to give us 12 volts over 3 ohms, and that is going to give us a current of 4 ampere. So a current of 4 amps is flowing in this first branch. To get I2, we have the voltage over the resistance, so that gives us 12 over 4, and that is going to give us a current of 3 amps flowing in the circuit. And our I3 is going to be the voltage over the resistance, and that is going to give us 12 over 6. That gives us a current of 2 ampere flowing in the third branch. A parallel circuit has the same voltage dropped across each of the loads. To get the total current that is flowing out of the voltage source, what we do is we find the sum of the currents that is flowing across each branch. So the total current that is flowing out from the voltage source, the total current that is flowing there will be 4 amps plus 3 amps plus 2 amps. 4 plus 3 is going to give us 7, and this gives us 9 amps. So we have 9 amps flowing out of the voltage source. Out of the 9 amps, 4 flow into this branch, 3 flow into this branch, and 2 amps flow into this branch. In this video, we have been able to learn a little background of Ohm's law, what it is about, and its mathematical expression. And also, we apply Ohm's law to circuit analysis. If you find this video helpful, you can give it a like below and give your reaction in the comment section below. Don't forget to subscribe to this channel so that you'll be able to see more of our videos as we are uploading it. Thanks for watching. Bye bye.